Hey everybody, welcome to 4.3 Remainder and Factor Theorems. What we're going to be looking at now is looking at how do you find if something's a factor of a polynomial. So looking at higher degrees. So we sort of looked at what the basic behavior is in the last couple of sections. We talked about quadratics. Now we're going to deal with degrees 3 and higher and just see how do we know if something is a factor, and then we'll go on even further on from that and look at solutions and solving and graphing. So what we're going to use is synthetic division. We're going to spend a lot of time actually today dividing things synthetically because it's faster than long. I know you guys love your long division, but we're going to see if we can remember how to do synthetically. So just like that extra credit we were working on last week. So when you do synthetic division, if I want to see if this original polynomial is divisible by that binomial, I'm going to set up what I would normally do for long division, but just the coefficients. So if I look at the original one, my coefficients are 2. Notice there's no x squared, so a 0, a 6, and then a 9. All right, then for synthetic, what am I dividing by? Well, the dividing by factor is x plus 1. Think about where the vertical asymptote would be for x plus 1. What shift would that have on the graph? Plus 1 sends it to the left 1, which means I'm dividing by a negative 1. So just be careful on that. Make sure you realize which direction you're going. If you see a plus, that's a shift to the left, so it's a negative 1. Okay, synthetic division works like this. You bring down the first factor and then you multiply. So negative 1 times 2 would be negative 2. And then we go ahead and add. That would give me a negative 2. Then you start the process again. You multiply. So negative 1 times negative 2, which would be 2. And then you add, which gives us 8. And then you multiply again, which would be negative 8. So we have a last number there of 1, which means this is not divisible. It has a remainder. So this last term is standing for the remainder. So this is not divisible. And as I work my way backwards, if you think about it, a degree 3 divided by a degree 1 should give me a degree 2 answer. So when I work backwards, this is my constant. This is the degree 1 term, and this is the degree 2. So I'm doing the division just without the variables. So the final answer for this division would be 2x squared minus 2x plus 8, and then I have a remainder of 1 over x plus 1. So it's not evenly divisible when I do those factors. Okay, so we're going to use that synthetic division to help us throughout what we're going to talk about today. Okay, so let's talk about the remainder theorem. Basically what the remainder theorem says is if you take two polynomials and divide them, so a polynomial p of x is divided by a factor, so x minus r, that's just like what we just did. Whatever the remainder is, it's equal to what you get when you substitute that value of r into the function. So this p of r, plugging in the number into the value, or for x into the equation, will give you the same answer as just doing your long division and looking at the remainder. So basically it's what's left over. So if I substitute a value in, that r, that number that I think is going to be a factor or a solution, if I plug it in, I get the same thing as if it is divided and I get the remainder. So we can double check and make sure that that is true. So for this first example, if I plug in negative 2 into that equation, so literally just plugging in negative 2 everywhere you see a y. So I'm going to plug in negative 2 in every single place. I'm going to have you do the arithmetic and just double check. So we're going to plug in negative 2 all the way through, kind of a pain. If I see what I get when I do p of negative 2, so I'm going to have you go ahead and plug that in on your calculator and figure it out, but the p of negative 2 I believe should be 10. That's going to give me the same answer if I divide it in synthetically. So let's double check the synthetic division. Degree 6 would be negative 1. There's no 5, so that would be a 0. Then a 4. There's no 3, so a 0. A 3, a 2, and a 2. And I am dividing by negative 2. So let's double check synthetic division and see if our remainder is equal to the same thing we get when we just plug the number in. So that would give you two different ways to check to see if something's divisible, if it's a factor or not. So we bring down the negative 1, multiply and add, 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 and then multiply and add. So there we go. Our remainder is 10 when we synthetically divide, exactly the same number as we got when we just substituted the number in. So if a number is going to be a factor, we can definitely check either by synthetic division and looking at the remainder, or we can plug the number in. Well, how does that help us? Well, here we get to the factor theorem then. It says a binomial x minus r is a factor of the polynomial if and only if P of r is 0. In other words, if you plug r into the equation, you get 0. Well, we just saw that we can not only plug it in, we can also do synthetic division to check if we get a 0 remainder, it is also a factor. So they mean the same thing. So plugging the value in is the same as dividing synthetically and getting a 0 remainder. The nice thing about synthetic is it also tells us what other factors we might have. Okay, so let's take a quick peek here and give this a try. It says, is x minus 3 a factor of that polynomial, that x to the third polynomial? Well, I can plug 3 in, so I can literally figure out p of 3 and see what I get for my answer. So one way of doing that is I could literally plug 3 in for each of these. So 3 cubed minus 3 squared minus 5 times 3 minus 3, and see if I get 0. If I do, that means it's a factor. If I don't, that means it's not. Well, that's one way to do it, and that just tells me, though, about that factor. What's probably even better is to divide it synthetically, so I can see not only if it's a factor, but what the other factors might be as well. So I'm going to divide this one synthetically. We can check over here and see too, but I want to check the synthetic factors and see if that works a little bit better for us. So I'm going to bring down the 1, multiply, add, multiply, add, multiply, add. Okay, so what does that 0 tell us? As you're talking to your computer right now, you're saying, well, it tells us that it's a factor. That means x minus 3 is a factor of that polynomial because we got a 0 remainder. So that means if I plug in 3, I'm getting 0 into that function. Well, the cool thing about this is not only now do I know that x minus 3 is a factor, I can write the polynomial that I have left, and I can see what other factors or the remaining factors would have to be by factoring the polynomial that I get when I do the division. So if I factor what's left, that would be x plus 1 and x plus 1. So I actually have 3 factors. I know all of them. If you multiply those 3 factors together, x plus 1 times x plus 1 times x plus 3, that original one that we checked, when I multiply them together, I will get that original polynomial. So it's a great way, this synthetic division, to find out if something is a factor, and not just that, what the other factors are as well by looking at what's left over. So that 0 remainder is super important. Okay, so let's see if we can figure out what the factors of this next one would be. Notice I'm not giving you an example to try. So you just know that this is your original polynomial, and you're going to try to guess and check to see what those factors might be. So we're going to use synthetic division because it's a little bit faster instead of just substituting values in. We're going to try to see if we have some number that might work. Okay, so we can try factoring by grouping. We could try guessing and checking. I'm just going to try guess and check and see if that works. So look at some numbers for the constant 10. What would be some numbers that would be factors of 10 that we might want to try? So numbers that divide in there would be 1, 2, 10, 5. So we'll try some of those numbers and see if any of them work. I'm going to try 5, see if that works. So I'm going to see if 5 is a factor, meaning is the binomial x minus 5 a factor? That's what I'm checking for right now by putting a 5 there. So is that going to be a factor of that polynomial? So let's double check. Maybe I got lucky on my guess here. Oh, I'm pretty lucky. Look at that. I got a 0. Okay, so that tells me it's divisible. So that means x minus 5 is absolutely a factor because I got a 0 remainder. And then I can take a look at the polynomial that I have left and see if I can factor that more to get my other factors of this polynomial. So it looks like an x plus 2 and an x plus 1. So if I would have guessed or checked either of those, I would have had the same result. I would have gotten a 0 remainder and I would have been able to factor what was left. So if you don't know any factors, we're just trying to guess and check and see if we can find one that works. So look at the constant, see if you can figure out what it is. You could graph it, see what it crosses the x-axis, but we're really right now guessing and checking. When we get to section 4.4, we'll talk about a more refined way of guessing and checking or factoring to be able to check what those numbers are. But for right now, just look at your constant, pick numbers that are factors of the constant, and you should be able to find something that works. Okay, let's take a look at this. A little twist on that idea for our last example. It says find the value of k so that the remainder is 0. In other words, that it's divisible. I'm going to go ahead and set up synthetic division for this. So 1, 6, opposite of k, negative 8. And what we're dividing by is 2, because the factor there, the r, is 2. All right, now when you do synthetic division, I can start off and I'd be just fine. Bring down the 1, multiply, add, multiply. I could get to there, and I can't really go a whole lot further because I don't know what the k is. But let's start working backwards. They said they want the remainder to be 0, right? So if the remainder is going to be 0, what number would I have to add to negative 8 to make that happen? Well, that would have to be an 8. Okay, well, in order for this to be an 8, that means whatever's down here in this little box times my 2 out front would have to give me an 8. So this number would have to be a 4 because 2 times 4 would give me an 8. So I can look at this column right here to figure out what k would have to be. Opposite of k plus 16 would have to generate 4 for my answer. So I can just solve that for k. So subtract the 16, so opposite of k equals negative 12, which means k would have to be positive 12. So you can actually do some cool things with this and figure out what values you have to have depending on what your functions are. Okay, so the assignment for everybody here is page 226, 14 through 40 even. I believe you have that already on your note sheet for yourself. And so if you want to just have a look at this so you can see what you're doing and you can have this up when you're working on that, then you can screenshot it if you want. So you have those and then all the way through number 40 for the rest of them. So I hope everything goes well for 4-3. Check your synthetic division, see if you get a zero remainder, then that binomial is a factor.